How does Pascal's triangle work?
We put triangular numbers in a triangle of number that contains other triangle numbers.
Cool!
Pascal's triangle is named after French mathematician Blaise Pascal, although other mathematicians studied it centuries before him.
Pascal's triangle is a triangular array of binomial coefficients. Pascal's triangles have a lot of patterns. Some of them include counting numbers, adding numbers, triangular numbers, square numbers, pentagonal numbers, hexagonal numbers, honey stick numbers, sum of row numbers, and Fibonacci sequence. The first pattern I'm going to explain is the counting number pattern. To explain the counting number more in depth, as you can see here, it goes 1, 2, 3, 4, and 5. And over here on the left side, it goes 1, 2, 3, 4, 5. All these are counting numbers going each way. The second pattern I'm going to explain is the adding number pattern. To explain the addition pattern more in depth, as you can see here, 1 plus 1 equals 2. 1 plus 2 equals 3. On the right side, 2 plus 1 equals 3. Back to the left side, it goes 1 plus 3 equals 4. Same thing over here on the right side, 3 plus 1 equals 4. And then 4 plus 6 equals 10. 6 plus 4 equals 10. 1 plus 4 equals 5. And 4 plus 1 equals 5. And that's your addition pattern. The third pattern I'm going to explain is the square number pattern. Square number pattern, you have 1 plus 3 equals 4, and 2 squared equals 4. You have 3 plus 6 equals 9, and 3 squared equals 9. And you have 6 plus 10 equals 16, and 4 squared equals 16. You also have the same thing going on the other side. Finally, I'm going to explain the sum of rows pattern.
The sum of rows pattern is quite simple. So 1 equals 1, so that equals 2 to the 0, because 2 to the 0 power equals 1. And then 1 plus 1 equals 2, so that would be 2 to the first power. And then 1 plus 2 plus 1 equals 4. So 4 equals 2 to the second power. So the numbers, the exponents of 2 keep going up. So you have 1 plus 4 plus 6 plus 4 plus 1 would equal 16. And 16 is 2 to the power of 4. Okay, for our example problem, we're going to do x minus 3 to the power of 4. And instead of doing x minus 3, x minus 3, x minus 3, x minus 3, which is a lot of work, we're going to show you how you can do it with Pascal's triangle. So, we have here the first 5 rows of, well, 4, because this counts as row 0, of Pascal's triangle. And since we want to go to the exponent 4, we're going to use the 4th row number. So we're going to use 1, 4, 6, 4, and 1. And you want to have a lot of space because you're going to be doing a couple steps with these. Okay, the next steps would be to plug in the x with all of these numbers. And then you're going to start off with having this number to the exponent of 4, and as you keep going down, they're going to go down by 1. So you're going to have 1x to the 4th, 4x to the 3rd, and etc., and you're going to keep going down. Okay, next what you're going to do is you're going to put in that minus 3. So you want to put it in parentheses after this problem that you just did. And this time it's going to go from 0 and it's going to go up. So 0, and then 4x negative 3 to the power 1, and then etc. The last steps for this example problem would just be to simplify. So overall you end up with x to the 4th power plus negative 12x to the 3rd plus 54x to the squared plus negative 108x to the 1st power plus 81.